Who are you, and how would you describe yourself, and what has been your main job of work?
I'm Malcolm Mackley. I was 32 years in the Department of Chemical Engineering, as it was called then, at Cambridge. I started at Cambridge in 1979 when I was 32, and I ended in Cambridge in 2011 when I was 64. I'm now retired at Salcombe in Devon as an emeritus professor of process innovation, fellow of the Royal Academy, and emeritus fellow of Robinson College. And I'm 78 years young.
Excellent. Looking back across your career, could you tell us about some of the key events and discoveries that you have made in the field of polymers, and perhaps the people who have inspired you?
Yes, I'd like to talk. I'd like to talk about the people in particular, and it all really, for me, started in 1968 when I went to Bristol University, and I was there between 1968 and 76, and I was jointly supervised, I think is the best way to describe it, by two individuals, Sir Charles Frank and um, Professor Andrew Keller. They were both brilliant and they changed my life. There's no doubt about that. They absolutely changed my life. I was doing a PhD studying around polymer science, and that was a key event. In 76, I went to Sussex University and met up with a person called Graham Knott, who was a brilliant brain, in fact, and he was working on oscillatory flow, and I worked with him on oscillatory flow. He was a control engineer. I was a lecturer in material science, but we did some, in my opinion, some really nice stuff on oscillating flows, and that's had a big influence when I came to Cambridge. So in 79, I was it 79, just checking. Yep, 79, I came to Cambridge. I started as a lecturer in chemical engineering and ended up as an emeritus professor of process innovation. And in that period, I think looking back, I was consumed by my research and supervising both postgraduate student projects and proper PhD projects. Absolutely consumed by it.
Must have taken up quite a lot of your time and sort of your energy in that.
Absolutely. So, and if I wanted to draw out three highlights, emerging from this, and in fact from an undergraduate, from a graduate fourth year project, came the plug flow as oscillatory flow reactor. Then there was a number of polymer processing and rheology apparatus that we developed. And there was finally there was a little excursion into the world of chocolate, and that was a lot of fun. And I invented a process for chocolate processing.
Fantastic. Moving on, what strategies do you use when you are dealing with adversity and difficult situations?
Well, that's a very difficult question to ask. And my instant response is to find a way around the problem. So if I have a difficulty, I saw some of my colleagues, they would choose a problem in the early stage of a career and then just ram their way through that problem. I think I was a bit different in terms of having a number of balls up in the air at any one time. And so if I had a problem, I would find somebody who could maybe help me with that problem, or find a way round a particular problem. Life's far too short to really get stuck.
Very pragmatic.
Yeah.
Okay. Now, what advice would you give to sort of early stage career academics?
Yeah, that's it depends whether that was 50 years ago or it's now. But equally, I would say there are three crucial things that early stage academics need to take on board. Maybe I didn't think this through at the time, but looking back, it's actually pretty clear to see what's involved. And the first thing is your research. Now, I would say that you need to have a label on your head. You need to put, Mackley polymers, Mackley whatever it is. But so you need to have a specific research target, so that which is identifiable and clear to everybody. So that's the research was for me absolutely crucial. Teaching is, of course, now very, very important. I can recall back in '79 when I applied or was invited to come to Cambridge, nobody actually talked about whether I was able to teach or not. And I think the bottom line is that I probably wasn't very good at teaching, but teaching is now crucial and very important, and you have to be prepared and ready to do that. So there's research, there's teaching, and finally, there's the dreaded administration. And administration, it's a very curious one, because when I joined, again, going back in time to '79, there were very few administrators at Cambridge, very few. The Department of Chemical Engineering was run by basically two people: Margaret Sampson, who was the secretary of the to the head of the department, and a man called Dennis Armstrong, who was a university lecturer, and the two of them basically ran the department. Now when I come back to Cambridge, I see a mass of support staff, which is not bad, but equally, I'm sure that current lecturers will have to be involved in administration. So you've got to take on those three elements. You've got to take on the research, you've got to take on the teaching, and you've got to be prepared to do administration. And there you are.
Excellent. Thank you. Okay, now more advice here. What advice would you give to students? And has this advice, or the advice that you would give, changed from how you would advise students, say, 20 years ago?
Well, again, that's a good question. Looking back, I haven't advised Cambridge students are super bright, and you have to take that on board. And they have changed in their backgrounds, but I haven't. Undergraduates, postgraduates, yes, I would advise them a lot, and I get fully involved with postgraduates. But undergraduates, they're super bright. They know what they're doing. They know how to work hard, and they know how to play hard. And they're best left, in my opinion, they're best left alone unless they need, for any particular reason, some help. But the difference that I have seen in the students is that when I first came, I would say industry, for example, would probably be looking at the 2-1s rather than the first class degree students, because the first class degree students were absolutely brilliant, but not necessarily streetwise. Now I would say that pretty well all students coming to Cambridge are very streetwise, and so that's a sort of significant change, really.
Now I'm going to shorten my next question because you've pretty much answered it actually about the sort of the work ethic of the students, what you've observed in them. But I think you've pretty much answered the question I was going to ask. But do you have any further comments on the sort of how you perceive students are nowadays?
Yeah, I've looking at my notes here. As I said, students. I don't think students have changed that much. However, I think the staff has changed a lot, and so in terms of work ethic, I don't. I'm trying to articulate a way of nicely saying this without being, dare I say, a boring old fart. But equally, when I was at Bristol, I came into on Saturday mornings. I would come in and talk to my professor because I knew it was the only time that he would have real time for me. So, and I was working until, oh, I don't know, 8 o'clock in the evenings, maybe in the department, doing experiments. And so the work ethic of the staff was very, very strong. And when I came to Cambridge in 79, there was a thing called the long vac term, which was a very busy period. And what else was there? There was something else. Oh, there were Saturday lectures. I don't know whether you still have Saturday lectures, but things were very busy, and the staff were generally always around in the department. And I wonder now when I come back to the department if that's still the case. So I think the behaviour of staff has changed rather than actually the behaviour of the students. But that's only a personal view.
That's a perfect answer. So, what area do you think the next big breakthrough in science will come from?
Well, again, and a huge and very interesting question to ask. Since I retired, I've started writing fiction, and so fiction's a wonderful thing because you can explore boundaries that you don't have to necessarily justify. So the current book that I'm writing is called Headland House, and I have 2 inventions in that, and one is an energy invention relating to electrolysis. So my fiction invention is the discovery of a super efficient membrane and conditions for forming hydrogen from water. So it's it's a wonderful thing, and so I can do that, and it's potentially going to change the world because energy is so important for the world. So my hope would be that somebody is going to come along with a way of resolving the energy problem, because most of the problems of the world are associated with energy. If you look at the Middle East, if you look at Russia, everything's about energy. And so a low-cost way of creating energy would be absolutely fantastic. And I've done it, but I've only done it in fiction rather than in reality. However, I think it's a highly plausible invention, so I'm quite pleased with it. And I have another invention as well, which is equally world-changing, but fun, because it involves your visual appearance and my visual appearance, and so it's a serious invention, but a sort of fun thing. So the energy bit is definitely, but what will come next? I really don't know. I suspect it could well be something to do with the brain, or it could be something relating to cosmology, because our understanding of the brain has moved on just incredibly in the last 20 years, say, well, you have to go back 100 years, but let's say it's accelerated in the last 20 years. So there it's a sort of wish list, really. but an energy a global energy invention would be fantastic, and that would have a very different complexion to the world that we live in at the moment.
Definitely. Great answer. Absolutely fabulous. Okay, so we're coming up to our final question.
Okay.
Although I may have a couple of other questions, I'll just slip in on you after this.
Right.
If that's okay. What are your thoughts on science and business partnerships and entrepreneurial thinking in the science and technology community?
Yeah, this is a big question, and something, as a, if you like, a pioneering, when you become a professor, you're under certain circumstances, you're allowed to say, well, what are you a professor of? And so that got me thinking, because I'm quite broad in terms of the sort of interest that I had. And so I decided I was a professor of process innovation. And so the word innovation was there. And that word wasn't there in 1979 when I came to Cambridge. So Cambridge was very, very academic in 79. And I know the science park had been formed by that time, but it was a rather distant beast, and it wasn't everyday parlance in terms of academic life. So the idea of industry was not universally accepted or thought of as being a good thing. And in fact, when I made this discovery on chocolate, in the extrusion of chocolate, there were those around me, and I have to say that some of them were in chemical engineering, were saying, hang on, chocolate is not really a Cambridge subject to be studying. And in fact, chocolate is fiendishly complicated, and countries' economies depend on chocolate. But it didn't fit in necessarily with the way Cambridge was as it was. So that's 1979. Now fast forward to 2025, and I see a huge difference. I see members of staff wanting to spin out companies. I see commercial motivation, internet, media profiles, etc., etc. So the world has changed, and not necessarily for the worse, and Cambridge has changed. So Cambridge has grasped industry, and then and to some extent has had to do that. And I was always needing industry to fund my research, in fact. So the companies that funded my research were ICI, BP, Shell, all the companies that are now seen as bad guys. So everything's changed, and I sense that the pendulum has maybe swung a little bit too far on the commercial side. So there's a sort of inevitability about it, but equally I would say that the pendulum has swung a bit too far, and you have to get this balance right. And it's a boring word to use, and it's a very difficult one to get the balance right between academic excellence and industrial relevance and commercialization. So it's a really tricky one, and Cambridge has moved, and initially there was nothing. There was absolutely nothing in terms of technology transfer. And I ended up getting into trouble on a number of occasions because there was only one person in the research section of the university that could sign off a contract. She was absolutely overworked. Just one person for the whole university had the authority to write and approve a contract, and sometimes that just doesn't work. You don't have time to do that. Now there will probably be 100, or there will be hundreds, literally hundreds. So I would say I would do a sort of advocate a John Major of doing back to basics. I would like to see the university strengthening on its academic side, but it has to go commercial as well. So there's an inevitability about it. There you go.
Brilliant. Excuse me. Absolutely brilliant answers. Thank you so much for doing this interview with me, and thank you so much for your excellent answers.